Hello everyone, welcome to BYJU'S Exam Prep, India's most comprehensive preparation platform. So I hope that you have got the results and many congratulations to all of you, those who got the desired rank, those who got the rank as per their expectation. And don't be sad that if you are not able to get the desired rank, because from the mistakes that you have done you can learn and you can attempt it for the next time, because this is not the exam which cannot be cracked by an average students or the poor students, you can say. Okay, so anybody can crack this exam, and ups and downs happens. Sometimes we prepare well, but we could not perform as per our requirement in the examination. So it happens with everyone. Most of us, like, I have talked with the many students, those who have prepared well but could not perform well in the examination because they didn't understand that which question has to be leave and which question has to be solved and which question has to be given attempt, second or third attempt. So it happens, and I will wish you all the best. Those who have not got the rank as per their desired and as per their expectation. So I will just give you the suggestion that if you have attempted for the first time, then you should always give you second chance for the gate examination, because in the second attempt there is a very high chance that you will get the desired rank. At least suppose you are getting 40 marks, then definitely in the next year you will be getting more than 50 marks, because you have prepared well and you have got the 40 marks. If you are able to get the 40 marks, that means you have you have done an excellent job, just that you have to revise the subject thoroughly. You might have not attempted the test series properly. You might have not done the analysis of the test series and analysis of the previous year. And maybe there are some tough subjects in which there are some tough topics. So those tough topics you have to work on. Otherwise, you will be able to get the overall marks more than 60. So good evening, Pinky, good evening, Ashok. Good evening, no, good evening. It is good morning, Ashok. And let's start the session with the introduction. So this is Saket Verma, and I'm having more than 12-year experience. So I have done MTech from IIT Guwahati in signal processing, and I teach the subjects like electromagnetic theory, communication system, advanced communication system, signals and system, and ICT, that is for your ESC. Okay, advanced communication and ICT are for ESC, and EMT, communication and signal system, both are for ESC and GATE. So there is a scholarship test because you have given the GATE 23, and if you want to prepare well, and then the BYJU'S exam prep team is always there, and we are going to give you a scholarship up to 90% on the preparation program. So we have the complete course for the GATE and ESC. So you can give this scholarship test and avail the 90% scholarship. And this exam is on 19th of March at 12 p.m. So you can register yourself. The link is given in the description. So this is the first question, because in the BARC examination, we will get the very simple question. So this is a type of question that you will get, and you have to solve it in a very short time. Okay. Okay, solve this question. So, a uniform plane wave with an intensity of magnetic field is 6 ampere. So, that is H is given us to us, that is 6 ampere per meter. And we have the traveling wave in a lossless non-magnetic medium. So, lossless non-magnetic medium is also given. Lossless non-magnetic medium is also given. So what is the meaning of the lossless? Mu r is equal to 1. Yes, hello Bharatwaj. So if you have already prepared EMFT, then you can attempt this particular question. That is very easy as per the BARC. Okay. Now you have got the H, and you have to calculate the electric field. So we know the relationship, that is eta is equal to E upon H. So from here we want to calculate E, which is electric field, that is eta into H. And for a lossless non-magnetic medium, it is 120 pi divided by root over epsilon r into H. So this is 120 pi into root over 36. The epsilon r is 36 and it is 6. So finally we will get the answer as 120 pi volt per meter. And if we want to write in terms of kilovolt, then it is 0.377 kilovolt per meter. Yes, Akhil, option C. Exactly. H is equal to E upon eta. Yes, that's what we have to apply. Coming to the next question. Coming to the next question. His first question for electrical, the first question for the double E students can also solve that question. Transmission line is there. The transmission line question is this. This class is useful for double E, not completely, because for BARC you have more the core part, that is the signal control, network, machine, power system, instrumentation, like that questions will be there. Not more questions from the EMT, and especially from the plane wave propagation and transmission line you may get, but in the transmission line, in the waveguide and antenna you will not get. So if you are double students, then you should be knowing that this is electronics section. So distortionless line. For the distortionless line, we know that R by L is equal to G by C, and we know that this alpha is equal to root over RG. If I put equation number 1, and Z naught is equal to root over R by G for the distortionless line. So if I multiply, I will get R is equal to alpha into Z naught, and I want to calculate alpha, which is R upon Z naught, and the value of R is 100, the value of R is 0.5, and the Z naught is 100. So from here we will get the answer as 0.0005 Napier per meter, option A. This is the same question of the gate. Okay, so the question will repeat in the BARC exam. So if you have solved the previous year question of gate and ESE, then you will see at least 10% of questions which are directly from the gate and ESE. This is the next question, question number 3. The electric field in a non-magnetic dielectric medium is the phase velocity we want to calculate quickly. Yes, so we know that for a lossless magnetic field, for lossless dielectric medium, Vp is equal to omega by beta, and the omega on comparison we have 10 to the power 9 and beta is 8. So after solving this, we will get Vp is equal to 1.25 into 10 to the power 8 meter per second. The answer is option B. Correct. Ashok. Coming to the next question. What will be the propagation constant? What will be your propagation constant? No, Gajendra, we don't feel like that because we have many students registered with us. So we will not suggest the students, those who have registered with us, to come in the YouTube. And similar way, there are number of students have registered in the different places. So nowadays, students don't watch the sessions live, and that's why we don't feel demotivated because we have given the some questions to practice. Those students are really interested and they want to do some practice, then they will watch it later on, because in the live session now we generally we talk about the other things also, and that is sometimes students feel of a waste of time also. So here when we compare with the standard function, that is 1 upon 50 is the alpha, right? And beta is your 2 pi. So we know that the propagation constant is alpha plus j beta, right? So it is 1 upon 50 plus j into 2 pi. So when you will solve it, you will get 0.02 plus j into 2 pi. That is meter inverse. So correct answer is option C. Correct? Next, question number 5. The electric field of a uniform plane wave is given by. The electric field of a uniform plane is given by. Equation is given, and now we have to calculate the polarization of the wave. We have to calculate the polarization of the wave. Yes, option is A, because as we can see that these amplitudes are equal, and along with that the phase difference between the y and x. The phase difference of y is 0. Here the phase of y is 0, and here you can see that the this is sine term. So because of the sine term, this is having the phase. This is minus 90. We can write. Okay. In fact, it will be. Yes, it will be y minus x, so it is 90. So it will be plus 90. So here it is the multiple of 2n plus 1 into pi by 2. So if the phase is multiple of pi by 2, that there is a phase shift of 90 degree and amplitudes are equal, then it is a circular polarization. Coming to the next question, what is the value of beta for this case? What is the value of beta? In signals and systems, the topics like a Z transform, and Fourier transform, basics of signal operations and systems, well, linearity, causality, the testing of the linearity, causality, stability, time invariance, the classification of signal, and the Laplace and Z transform and Fourier transform. These are the important topics for the BARC exam. Option is C, yes. So here you can see that we want to calculate the value of beta. So beta is equal to omega by C root over mu r epsilon r, and the omega is 10 to the power 8 and C is 3 into 10 to the power 8 and mu r is 1 and epsilon r is 9. So we will get 1. So beta is 1. Yes, Ashok is getting A, but okay, leave it. So this is the next question. The electric flux density D is given in the spherical coordinate system. You have to calculate the value of volume charge density. You have to calculate the volume charge density. So we know the Maxwell equation. Okay, we know the Maxwell equation, that is rho v is equal to divergence of D, divergence of D. So the divergence of D in the spherical coordinate system 1 upon r square del upon del r square into dr. The rest of the term we don't need to take because this is only the r component which is given to us. So 1 upon r square del upon del r in bracket r square into theta upon pi r square and 1 minus cos 3r. Okay, so this r square and this r square will get cancelled, and when we differentiate it, we will get sine theta theta into sine 3r multiplied with 3 divided by r square. So 3 theta upon r square. So 3 theta upon pi r square and sine 3r. So that is our option C. Option C. Okay, the option C will be the right answer. 3 theta upon pi r square sine 3r. Next is, if the VSWR is 3, then the return loss of the transmission line. So return loss is given by minus 20 log of magnitude of reflection coefficient, and magnitude of reflection coefficient, sorry, can be calculated as s minus 1 divided by s plus 1. So this is 3 minus 1 divided by 3 plus 1. So we get 1 by 2. So the return loss is minus 20 log of 1 by 2. So that is nothing but a 20 log of 2, and this is 6 dB. Okay, 20 log of 2 is 6 dB. The answer is option B. Now solve this question. The depth of penetration The depth of penetration of an electromagnetic wave in the medium having a conductivity at a frequency of 20 megahertz is 25. The frequency at which the depth of penetration becomes 50 is. So you know that the skin depth is inversely proportional to root over frequency in a good conducting medium. So here we can calculate delta 1 upon delta 2 is root over f2 upon f1. Now the depth of penetration is given as 25. So this is 25 and delta 2 we want to calculate and the frequency, okay, we want to calculate the frequency in fact. The frequency we want to calculate. So this is 50. The frequency f2 we want to calculate and the frequency f1 is 20. So how much it will be? 1 by 2, 1 by 4. When we square it, this is f2 is equal to 20 by 4, that is 5. So we get 5 megahertz. Option A. Yes, 1 upon root f. Yes, 5. 5 is the right answer. Next, for a sinusoidal current distribution, the ratio of physical length and the effective length of a half wave dipole antenna. So this is the something which you should know, the value we should know because this is not the formula exactly. The effective length for a half wave dipole. This type of factual questions also comes in the exams like ESE, BARC and any other PSU. So effective length is given by lambda by pi and the physical length is given by it is lambda by 2. Physical length, that means half wave dipole will have the length as lambda by 2 but the effective length is lambda by pi. So we want to calculate the ratio of physical length divided by effective length. So this is nothing but a lambda by 2 and this is lambda by pi. So we are getting pi by 2. What is the value of pi by 2? 1.57. 1.57 will be the answer. This is for the sinusoidal current distribution. Okay. Now, next question, a 50 ohm lossless transmission line is terminated by load impedance ZL is equal to 50 minus J75 ohm. If the incident power at the load is 100 milliwatt, then the power dissipated by the load. So you know that the power dissipated by the load is nothing but the power incident multiplied with 1 minus magnitude of gamma square. So this is the formula, the power which is delivered to the load, which is 1 minus gamma square, and the power which is reflected back is mod gamma square. So power input is given, you have to calculate only the magnitude of reflection coefficient, and the reflection coefficient is given as ZL minus Z0 divided by ZL plus Z0. So here we have 50 minus J75 minus 50 divided by 50 minus J75 plus 50. So when we will solve it, this will be minus J75 and how much it will be? 100 minus J75. So it is minus 3J and it is 4 minus J3. Okay, so magnitude we want to calculate. So magnitude will be here 3 and this is root over 4 square plus 3 square which is 5. So 3 by 5 which is 0.6. So the power delivered to the load is 100 milliwatt and 1 minus 0.6 square. So how much it is? 64 milliwatt. Okay, 100 1 minus mod gamma square, this is 0.36, 1 minus 0.36, 0.64 and multiply with 100, 64 and milliwatt are already there. So the answer is 64 milliwatt. Now question number 12. Question number 12. At a distance of 6 km from an antenna, the field strength is 12. The field strength at a distance D is 6 volt, means the field strength is reduced by half. When the field strength is reduced by half, what should be the distance? When the field strength is reduced by half, what should be the distance? What is the answer of this question? Very easy question. We know that the electric field is inversely proportional to R. So if you will increase the distance, then the electric field also decreases. So when you increase the distance, electric field decreases. So here you can see that the electric field you have reduced by half. That means distance you have to increase by 2. Okay, because the electric field is reduced by half, distance you have to increase by 2. So distance was 6 kilometer. Now when you will go to the 12th kilometer, then the electric field strength will reduce by half. So answer is 12. Now coming to the next question. It is required to propagate a 30 gigahertz signal in an air-filled rectangular waveguide where A is greater than B in the T01 mode in such a way that lambda naught divided by lambda g is 0.80. If the dimension of the waveguide are A cross B where A is greater than B, then the narrow wall dimension, that means A we want to B. Narrow wall means smaller length, wide means A. So it is given as TE01 mode. So what is the cutoff frequency for TE01 mode? So the cutoff frequency for TE01 is C upon 2B, because the overall formula for the cutoff frequency is C upon 2 for air field. This is M by A whole square plus N by B whole square. So if I put 01, then I will get C upon 2B. Okay. So what is the value of this cutoff frequency? We have 3 into 10 raised to power 10 if I want to calculate in centimeter, and 2B. B we don't know. Okay. Now what is the operating frequency? The operating frequency is given to us. That is it is propagating at 30 gigahertz. So F is equal to 30 gigahertz. Okay, so when I calculate Fc upon F, then I will get 3 into 10 to the power 10 divided by 2b into 1 upon 3, 30 into 10 raised to the power 9. So this will get cancelled and we will get 1 upon 2b. So Fc upon F is 1 upon 2b. Now we have this ratio. So this ratio gives the guide wavelength. Guide wavelength is given by lambda naught root over 1 minus Fc upon F whole square. So lambda g upon lambda naught upon lambda g is 0.80. So this will be root over 1 minus Fc upon F whole square is equal to lambda upon lambda g, which is 0.80. Okay. So from here, when I square it, I will get 1 minus, and I also am substituting the value of Fc upon Fb. So I am getting 1 upon 4b square is equal to 0.64. Okay, so after calculating this, I will get the value of b, I will get as 0.83 centimeter. Okay, when you will solve this equation, you will get value of b, which is 1 minus 0.64, that is 0.36, and when we take square root, you will get 0.6 divided equal to 1 upon 2b. So b is equal to 1 upon 1.2, and finally you will get 0.83. Now the 14th question, a uniform plane wave in the air is normally incident on a dielectric material, and the electric field of the transmitted wave is given, then the electric field expression for the incident wave. So what is the expression of incident electric field? We should have the peak value. Okay, and this is cos, the cos is missing here, this cos omega t minus beta 1, because incident and the transmitted wave will be having the different medium. So beta 1 z, the direction of the incident wave will be in the direction of transmitted or vice versa, and the direction of electric field will also remain same. So this is ay. Okay, now yes, 0.83 Pinky, correct. Now, in this question, we want this EI0, this beta 1. So, how can you calculate the beta 2? Beta 2 is given, which is root 3, and this is nothing but a omega by c root over mu r2 and epsilon r2. Omega by c is nothing but medium 1. This is your beta 1, which is omega by c, because for air field, beta 1 is omega by c. So this is, we can write beta 1, and the medium is having the dielectric constant as 1 and 3. So from here you will get the beta 1 is equal to 1. So the value of beta 1 is 1. So first thing we have calculated. Now we want to calculate the EI0. So we know that ET0 divided by EI0 is equal to tau. That is the transmission coefficient. So if I want to calculate EI0, I need a tau. Okay, because ET0 is given. This 7.32 is nothing but the value of ET0. So now I want to calculate the value of tau. So this tau you can calculate 2 into eta 2 divided by eta 2 plus eta 1 for normal incidence. This is 2 into 120 pi divided by root over epsilon r mu r, which is 3. Same 120 pi divided by root 3 plus 120 pi. So 120 pi will get cancelled, and we will get 2 upon root 3 whole divided by 1 plus root 3 upon root 3, and this root 3 and root 3 will get cancelled, and we will get 2 upon 1 plus root 3. So 2 upon 1 plus root 3, what will be the value of tau? What will be the value of 2 upon 1 plus root 3? 2 upon 1 plus root 3. Let's calculate. 2 upon 1 plus root 3. It is 0.732. It is 0.732. So we have got the value of tau also. Now ET0 is 7.32 and tau is equal to 0.732. So the value of EI0 is 10. The value of EI0 is 10. So now I will substitute the value of EI0 here, which is 10, the value of beta, which is 1. So this is 10 cos omega t minus z, that is option B. Minus z because the direction of the incident and the transmitted will be same. Yes, Ramesh Srivastav, it is very good. It is very good, actually, college. The BITS Pilani, if you are looking and if you are suppose getting the microelectronics in the BITS Pilani, and in fact the microelectronics in any of the BITS branch, like you, if you get the microelectronics in Pilani, Hyderabad or Goa, in any of these three, if you are getting the admission, then you will have very bright future in terms of your internship, in terms of your placement. So remember one thing, getting admission into the BITS or any IIT is not sufficient. You have to work hard there also for another 1.5 year. Okay, up to third semester you have to work hard if you want a good placement in any campus. Either you take admission in the NIT, IIT or BITS. So all of these colleges are the premier institutes of India, and all are having more or less average to good placement. NITs are having average placement, IITs are having good placement, BITS are having good placement. But when you will fall into that category, when you will get placed, when you will have some knowledge, when you will have the potential to crack the interview of the placement. It is not always necessary that just you have taken admission into IIT or NIT or BITS, your future is bright. It is itself not sufficient. You have to work hard there for next 1.5 year. This is the last question for the day. Question number 15. And a radar system which operates at the wavelength 3 centimeter with the peak pulse power 600 kilowatt with an effective aperture area 5 meters square, minimum detectable power 10 to the power minus 13, and the cross section area of the target is 20 meters square, then the maximum range is. The maximum range of the radar is given by Pt into Ae into sigma upon 4 pi r square into minimum detectable power whole to the power, not r square, it is not r square, 4 pi lambda square actually. Because of r square we have got this r max, na? So if I substitute the values, this PT is equal to 600 into 10 raised to power 3. Effective aperture area is 5 and the target has area 20, and 4 pi lambda is given as 3 into 10 raised to power minus 2 whole square, and minimum detectable power is 10 raised to power minus 13 whole to the power 1 by 4, and then you will get 717.65 kilometer. This will be your answer, option number B. So that is the question to recall the formula of radar, because sometimes in the PSU exams you will not get the exact uh, question from the GATE syllabus, because the radar is also the part of microwave, and the microwave basic questions also can come in the PSU exam like BARC. So this is the question number 15. So this is all about the today's session, and this was the BARC Super 15 question. That means this type of questions you will see in the BARC examination. After the BARC examination, let me know how much helpful was this session. Come back and comment on this session so that I will also come to know that how much useful these sessions are for all of you. Thank you for watching this session. Nearly 2023 crash course has already been started in our channel. So if you are from the CS background and or you are from EC, then you can join this crash course. For the EC branch, it is quite difficult because most of the subjects are from CS. But if you are willing to appear in this exam, then this crash course will help you. And Monday, Wednesday, Friday will be their technical session, and every Saturday there is exclusive session of aptitude, and that has been started from that is starting from 18th of March. And copy with concepts, we are starting the basic concepts with the help of some 3D pictures or the animations. We are trying to make you learn the more detailed concept of the some specific topic, and this will come twice in a week, Wednesday and Sunday, and Tuesday and Saturday for CS. That is also starting from the 19th of March. So subscribe the channel, stay tuned with us, and UPSC ESE result has out, the GATE result has out. so you can share your result and you can avail the amazing benefits. Thank you for watching this. Let's meet in the next session, which is maybe coffee with concepts, and also the post guidance program for the GATE 23 aspirants, those who have qualified. We will be coming live to guide you what are the possible colleges you can get, mark versus gate score versus the IIT, what are their cutoffs. So all these things will be discussed in this channel. So don't forget to subscribe this channel and join our Telegram group for more update and the PDF. Thank you. Yes, Pinky, that's what I'm saying. If you are willing to appear on the NILIT, then you can take the CSE syllabus, but it is difficult for us to cover the CSE syllabus in detail.